In this lecture, we will discuss one question of your rocket propulsion. Topic is multi-staging. We have in rocket propulsion we have multi-staging, very important topics. Many times they have asked a question for from multi-staging for 2 marks. Kind of let's say we have a two-stage of rocket, and in that we have a change in velocity. Then what will be the total velocity? So this kind of question they have asked. So if you see, generally multi-staging is used for the purpose of multi-staging or advantage of multi-staging is that when you have a multi-staging, let me draw the first the then I will laterally I can explain. Okay, so this kind of we have a let's say rocket of multi-stage. Okay, so this is, let's say, this is first stage, and this one is second, this one is third, this one is fourth stage. Okay, and in that we have a payload at this section. So what happens, multi-staging we use generally because, let's say, we have burned the first stage of whole propellant. So what we will do now, we are going to burn the second stage of propellant, right? So in that case, now first stage propellant is gone. So what we can do, we can left out the first stage of structure. So what will happen, first stage of propellant is already gone. Now second stage of first stage of structure will also we can left, we can eject that. So what will happen in that case, mass of the structure of first stage will reduce, right? So ultimately what will happen, rocket whole weight will reduce. So what will happen in that case, when mass of the rocket will less, we will get more velocity, or we will get more change in velocity, right? So this is the advantage, or this is the basic, we use multi-staging of rocket. Okay, so let's say we have this kind of rocket and we have a CD nozzle, right? And this is the payload section of rocket, right? So they have given the, okay, let's say, now let's read the question. So what they have given, so they are asking the question is given, the jet velocities and a mass ratio of 4-stage rocket is given. So they have given the data of 4 stage, first, second, third, fourth, they have given everything. So first stage, the whatever propellant will burn, accordingly they will it will exceed the velocity of 2000 meter per second, right? They have given in 2000 meter per second, and mass ratio of that first stage is given. Similarly second stage, and depending on that velocity, what velocity it will eject, they have also given. So they are asking, find the total velocity increment in kilometer per second of the rocket. So they are asking, after the using 4 stage, what will be the final velocity of your rocket. That means after the burning of first stage of propellant, you will get some velocity, let's say 3000. After the second stage you will get, let's say, 4000, because mass of the structure is gone from first stage, right? So velocity will increase definitely. From third stage you will gain more. From fourth stage you will gain again more. So they are asking, what will be the total velocity at the end of this whole propellant burning of whole stage. So they are asking this. Okay, so okay, let's see what now let's solve the question. So if you see, now we have the formula of, okay, let me write the formula first. So this is nothing but, yes, G into ISP ln of m1 divided by m2. Let me explain what is the each and every term. So this is delta U is change in velocity, and this is your gravity, and ISP is a specific impulse of that propellant, and m1 here is a initial mass of your rocket. What is the initial mass of rocket after whole propellant and structure weight and payload weight, and m2 is the final weight of rocket of your burning of propellant. So this is the 4-stage rocket. So what we'll do, we will calculate the each stage change in velocity. So what will happen, this change in velocity is given by how much mass difference you have. That means how much mass is changing after your burning of propellant. So this is m2 is total mass when when your propellant is burned, right? So depending on that you will get some velocity, and also depends on this is also depends on specific impulse and gravity. So this is the formula basically we have. So what we'll do in this case, we have to calculate this whole change in velocity of four stage, altogether four stage. So what we'll do, as of now they have not given the gravity, so we have to assume it as a 9.81. Okay, so okay, if you see precisely, ISP is given by Cj upon G. So that means specific impulse is given by how much velocity, exit velocity divided by gravity. Okay, so if you see if you derivate this, Cj will be nothing but ISP into G. So now if you see in this equation, we have already this, right? So you can directly write it as a Cj. For each stage they have given Cj, that means this Cj is the exit velocity of your propellant, right? So I can write similarly Cj of 2, this is Cj of one stage, ln this one be again mass 1 divided by mass 2. So this together is a mass ratio. This is nothing but mass ratio they have given already. Okay, similarly they have, this is the mass ratio of first stage, this is the mass ratio of second stage, and so on. This is Cj3 ln of again m1 divided by m2. Each stage they have given mass ratio. First for 5, second is 8, 12 and 8. Okay, again if I write for this, I will get ln of m1 divided by m2. So if they have given the specific impulse and gravity, so you can use this formula directly. From here you can write Cj equals to specific impulse into gravity. In that place you can write directly Cj, right? So I'm using this form of formula to directly compute the change in velocity using this much of mass ratio, this much of propellant, we can say. So if you calculate this, put all this value, they have given all this value, Cj they have given, mass ratio they have given, you have to put all this and calculate this. Okay, I have all this value as a, okay, let me write the value. I have already calculated this. Yes, if you calculate for the first stage, mass ratio is given 5 and Cj they have given 2000 meter per second. So you will get this as a 3218.88 meter per second. So from first stage you are getting this much change in velocity in rocket. Okay. Similarly, if you calculate for second stage, mass ratio they have given 8. This is nothing but 8, and Cj they have given 2200, right? Okay, let me change the color. Yes. So if you put all this value and simplify that, you will get this as a 4574.77 again meter per second. Again, if you calculate for the second stage, mass ratio they have given as a 12, Cj they have given as a 1800 meter per second. So if you calculate this, if you put this as a Cj, if you put this in meter per second, you will get change of velocity in meter per second, because this is the unitless term, right? Okay, you will get this as a, I am getting this as a 4472.83 meter per second. From the fourth stage, I am getting this as a, if you put this, this is given by, this is again given 8, this is not 18, this is 8, and this is this 2800. So if you substitute again, you will get this as a 5822.43 meter per second. So now they are asking the find the total velocity increment. So that means total velocity will be this change in velocity by second stage change in velocity by first, second, third, and fourth. So substitute all this, add all this, you will get this as a 18088 point something, which is in meter per second. So if you divide this by 1000, you will get change in velocity is as a it has a 18.08 kilometer per second. So that means in a in 1 second, in per second, you are getting 18.08 kilometer distance you are covering, they are saying. Okay, so I hope you got how to calculate or how to use this formula, and depending on that you have to pick the equation. Okay, so okay, let me write the one more formula of this that formula is just extension of this previous formula. Okay, in the different term, this formula is just given by, again, change in velocity is equals to, this is in different form. If you see, g into isp ln of 1 plus lambda divided by this. Okay, so this is the also important formula. You will get similar value, but this is given in this lambda is a payload ratio. Okay, and this one is a sigma is a structural ratio. Okay, and this is again is a payload ratio. So when they have given data in this form, structure ratio or payload ratio, we can directly use this formula to calculate change in velocity from that stage. So again, if you see this g into isp, you can write this as a cj, which is a exit velocity. Okay, so I hope you got the idea how to use these equations and what is the significance of this equation they have given. Okay, if you have any doubt, you can ask me in the comment section. I will try to answer that. Okay, let's meet in the next section. Thank you.